This webcast is looking at Worksheet 1B, where we're learning how to do unit conversions. And let's see, so I will start with the first problem, where we're given 0.00372 meters. We'd like to know how many millimeters that equals. So I want to start by writing the quantity that I'm given along with those units. And then I set up a grid that has horizontal fraction bars. That's important. I don't want the diagonal fraction bars because it might confuse me of what units are on top, what units are on bottom. So I have meters, so they're on top, and I want to convert to millimeters. So the meters need to cancel. So when I set up my conversion factor, I need something that has meters in the bottom so that the units of meters will cancel and I'll be left with millimeters. To set up this conversion factor, I use my understanding of what the prefix milli means. Milli means multiply by 10 to the negative 3. So 1 millimeter is 10 to the negative 3 meters. And when I do this math, so I'm taking 0.00372 and I'm dividing by 1/1000th, right? And that gives me 3.72 millimeters as a result. Okay, let's do the next one. So I have a quantity of micrometers. So I start by writing that, and it's a lot of them. And I'd like to know how many meters that is. So I set up my horizontal grid. This time I want micrometers to cancel, and I'm going to get meters as a result. And so I need to set up my conversion factor, and I know that 1 micrometer is 10 to the negative 6th meters. And if I do this math, I end up with 885 point. Okay, let's go down to the next part, because some conversions require more than one conversion factor. Remember, each conversion factor is really equal to 1, right? Because whatever's on top equals whatever's on bottom. And I can multiply by 1 as many times as I want to, and I'm not changing the original quantity. Okay, so let's look here at number 5. It says how many micrometers are in 2.4 centimeters. So 2.4 centimeters is what I've been given, and I'm going to set up my horizontal grid. Now, I am not memorizing the conversion between centimeters and micrometers. I know that if you are thinking about the metric number line that we've used in class, you might be able to figure that out. But a safer way to do this conversion is to first go from centimeters to meters, because I know what the prefix centi means, and then to go from meters to micrometers. That way, I'm only using conversion factors that I am able to easily take out of my memory, and I won't make mistakes, most likely. So I know that 1 centimeter is 1/100th, or 10 to the negative 2 meters. And I know that 1 micrometer is 10 to the negative 6th meters. And so if I do this math, I can see that centimeters are canceling, meters are canceling, and I'm going to be left with, let's see, I'll take my calculator. And I get 24,000 micrometers. Okay, and let's look at converting I want to go down and do one of the ones that involves time. So let's look at number 8. I have a large number of seconds and would like to convert it to years. So I write down what I have to start with. I have 9.533 times 10 to the 12th seconds, and I want to convert to years. Now, I know that there are 3,600 seconds in 1 hour, and then if I think about it, I know how many hours are in a day, right? There are 24 hours in a day, and there are 365 days in 1 year. And so seconds are canceling, hours are canceling, days are canceling, and I'm left with the unit that I'm trying to get to, which is years. And so to do this math, I take the 9.533 times 10 to the 12th, I divide by 3,600, and then I divide by 24, and I divide by 365. And so I get 302,289 years. This was a lot of seconds. Okay. Let's look at one of the examples from part 3. Because these problems are unit conversions, but they require us to use a ratio to solve the problem, to answer the question. So this first example, we have a water bottle that's 20.3 centimeters tall, just a normal water bottle. And we want to know, if I stack those water bottles on top of each other, how many would it take to equal the height of the Batman building downtown? And that building is 188 meters. So I'm trying to figure out, in the height of the building, how many water bottles could fit. So I think I want to do this kind of ratio, and if I use the information that the problem is giving me, the height of the building is 188 meters, each water bottle is 20.3 centimeters. So I have an issue here. These are mixed units. They're not the same. And so I must convert to the same unit before doing this math. It doesn't really matter if I work in meters or centimeters. Either one, I will get the same answer, but they must be the same unit. Okay, so I'm going to work in meters, but again, I could work in centimeters. So I'm going to convert. I'm going to say that 1 water bottle is 20.3 centimeters, and I'm going to convert that to meters. So I need to go from centimeters to meters, and I know that 1 centimeter is 1/100th, or 10 to the negative 2 meters, and so it is 0.203 meters. Now I can go back and do that ratio. 188 meters divided by 0.203 meters. See, now the meters cancel, and I'm going to be left with the number of bottles. So 188 divided by 0.203, and I get 926 bottles. I'm just rounding to the nearest whole bottle. Okay, so when you are solving a problem that requires a ratio, make sure that the units are consistent. You cannot do the division with mixed units. And then the final example, I'm going to do one from part 4 here. These are some problems where we have conversions that are going to require us to convert multiple dimensions. Let's just look at the first example. I have the quantity I'm given is 11.2 meters per second. Okay, so if I wrote that, it would be 11.2 meters per second. And then I'm going to set up the rest of my horizontal grid. And notice that I have two dimensions that need to be converted. I want to take the length dimension, meter, and convert it to miles. And I want to take the time dimension, seconds, and convert it to hours. Okay, so they're giving me here the conversion from miles to meters. And I need to put it so that meters is on the bottom of my fraction bar and miles is on top. By the way, notice that I'm using the symbol MI to represent miles because I use M to represent meters. We don't want to confuse them. So 1 mile is 1,609.34 meters. If I do this math, meters will cancel and I would have miles per second. But I also want to convert the time dimension, and I want to go to hours. Since I want seconds to cancel, I need to put seconds above the fraction bar and hours below. And I know that 1 hour is 3,600 seconds. Okay, so I'm going to be left with miles per hour when I do this math. And so the math would be, I multiply all the things that are on top, so 11.2 times 3,600, and then I divide by anything that's on the bottom, which is 1609.34. And so this is 25.054 miles per hour.